Hello everyone, I welcome all of you to our session 4, Challenges in Wearable Tech and Pathways to Innovation from the module Animal Science and Technology. At the end of the session, we will understand why the beef system is going to be different from the dairy cows. Dairy cows are handled daily, so collars can be checked and batteries can be replaced. But when you take a beef cattle, they are often on extensive pastures where there are less human contact and they grow in a more rugged environment. So the collars can fall off and it can be damaged by the brush, wires, or the weather. So we always have to ensure the power supply and the data connectivity are tougher in the remote areas. That's the reason why we prefer a controller board or a microcontroller board which supports the durability, power, energy, and connectivity cost, especially because the tech must be inexpensive or it clearly pays off in improved growth, health, or the labor savings. So we will be using an Arduino Nano here. Arduino Nano is basically a very small microcontroller board that is used to control the electronic devices. It's about the size of a USB flash drive where it can read the data from the sensors and control the devices like LEDs or motors or buzzers or any external peripherals. So you can think this like a tiny brain of electronic system that makes a decision based on the program what we write. So Arduino Nano is, to be very brief, it is a small programmable board that reads the sensors, controls the devices in order to automate any real-world task. You can look into the pin diagram on the left-hand side. Please don't get panicked, dears. It's actually very simple because it's going to have only 3 important parts. The first one is the power pin. So power pin is all about like how we are giving the supply to it. So you can see here V in. So V in is used to power the board from an external battery, 7 to 12 volt. And then we have the 5 volt here. It provides a regulated 5 volt for the sensors or the modules. Then we will be having a 3.3 volt. So that provides 3.3 volt for the low power sensors. Then obviously we have the ground and the reset pins. The ground and the reset pins just completes the electrical circuit, and reset basically restarts the program which is running on the board. So for example, a soil moisture sensor needs 5 volt and ground in order to work. Okay, so that can be connected to this Arduino Nano directly. Then we have the various analog pins, which is being named from A0 to A7. So these pins, it reads the continuous value from the sensors. So let's take the analog pins. Some examples might be the soil moisture sensor or the temperature sensor or the light sensor. So what these analog pins will do is it converts all those signal from the sensors into a number from 0 to 1023. So this is what the analog pin does. The analog pin converts the signal into the numbers from 0 to 1023 using something called as an ADC. ADC represents analog to digital converter. So let's assume the soil is very wet. Okay, so the value may be in 900. And if the soil is very dry, the value may be around 200. So basically, this particular analog pin does the value of converting the signals into the numbers. Then we have the various digital pins. You can see D2, D3, D12, and then you have D13, from D2 to D13. So digital pins works only in 2 states. It works in 1 or 0. 1 represents high, which is on, and 0 represents low, off. So these pins are used to control the LEDs or buzzers, relays, any motors. Example, we can connect the pin D3, turn on the LED, or pin D5, like controlling the motor. All this is possible with the help of the digital pins. Apart from this, there are some special pins present. So these pins have some additional functions. Now let's take the D0 pin. The D0 has something called an RX, which is used to receive the serial data. And D1 has a special function of TX, which is used to send the serial data. Then the D11, D12, D13, these are used for the SPI kind of communication with the sensors. So we will learn in a detailed way what is SPI and what is pulse width modulation or I2C in our upcoming modules. But just for our understanding, we have a power pin, analog pin, and digital pin. Power pin gives the electricity, analog pin reads the sensor values, and digital pin is used to control the devices like LEDs and motors. Okay, so an Arduino Nano pin diagram, it's going to just show you how the board connect to the various peripherals. So whenever you work on any microcontroller board, we need to download the data sheet first and take a look at the pin diagram. If you go to the Arduino Nano website, this beautiful pin diagram you can see. I will also share this in the description, dears, the link of the Arduino Nano page, so you can go over there and then download it. Right. So with this basic understanding, let's move on into doing our project. So we always use the Tinkercad platform in order to do our project. Let's try a different platform today called Wokwi. So all of you please go to Google and type wokwi.com. Wokwi is just similar to the Tinkercad. It's a free online electronic simulator that is going to allow you to build, wire, and program the Arduino or any kind of ESP-based circuits directly on your web browser. So you don't require any hardware here. Anything you do on the simulation, then later you can do it in the hardware and it still works. So I always trust Tinkercad and the Wokwi platform. It behaves like just working on a physical board, but everything is going to happen virtually. So you can do some safe experimentation here where there is no risk of wiring errors damaging the components. And let's try to do the project over here. I hope all of you have logged into wokwi.com, dears. Once you are into the wokwi.com, just give sign up. Try to just log in with Google. And you can see here, I just logged in with my Google. So these are the various controller boards which the Wokwi supports, and we are going to prefer Arduino Nano here. So just click Arduino Nano. This is just like our Tinkercad, dears. So it's easy for you once you look around the platform. It's just replicating our Tinkercad platform, so it's a bit easy for us to understand. You can always save the project title, which is on the top left. So you can just save it and rename it. Everything will be stored on your cloud. So this is the Arduino Nano, which I was talking to you. So Arduino Nano, again, it has power pins, analog pins, digital pins. That's all. Okay. Let's try to add the remaining component here. So today we are going to use a motion sensor. The motion sensor value is HETS CSR501. No worries, we are just going to look into that component. Okay, so in order to bring that component onto your dashboard, please click this plus option and then type PIR motion sensor. This is the first component. The second component is an LED followed by a resistor. So we would be in need of 4 different components in order to do the project today. I'll explain the workflow, how it works, and what is the logic behind the code and everything, dears. Just try to bring all these 4 components onto your screen: a nano board followed by a PIR motion sensor, an LED, and a resistor. We're going to use 330 ohm here. So just click the resistor and change the value. Now let's start to give the connections. So an LED has two different ends. So we are going to connect the anode to one end of the resistor. And the other end of the resistor, we are going to connect to D8 pin. Again, you can connect to any of the digital pins. I'm just randomly picking up D8. And then we are going to ground this. Okay. So with this, the LED connections are done. Now it's time for us to give the connections to the PIR, which we call it as a motion sensor. A motion sensor has three different pins: VCC, out, and a ground pin. G and D is ground. We are going to connect it to the ground. Next, we have the out pin. The out pin can be connected to any of the digital pins. This is going to act like an interrupt. I'll tell you what is an interrupt and the importance of interrupted ears. So just connect the out pin to any of the digital pins. Okay. So I'm going to connect here to pin number 2. You can always change the colors. If you're getting confused, like there are too many wires, and if you feel confused, always change the colors of the wires. That's for our understanding. And then we have the VCC. So we are going to connect the VCC of the motion sensor to 5 volt of the nano board. So with this, the connections are done. We have connected the LED pin to D8. A PIR motion sensor has 3 different pins. VCC is connected to 5 volt. Ground of the motion sensor is connected to ground of the Arduino board. And then we have the out signal, which is being connected to D2. Again, you can use any of the pin pairs. Accordingly, you should modify the code. So I'm going to share the code in the description and as well as in the comments, which you can just paste it. I hope all of us are on the same page. I'll explain how this program works line by line. So please paste the code, whatever is being given in the comments or in the description. Interrupt before moving on into the code. So let's understand what is an interrupt first. Interrupt is something that stops the normal work of the system and asks it to handle an urgent event immediately. Let's imagine this scenario with an analogy of a teacher in a classroom. So the teacher is teaching a lesson and so she's writing something on the board explaining and teaching. The teacher continues the lesson normally. Suddenly, the fire alarm rings. What happens? The teacher immediately stops the teaching and handles the emergency, right? So the process of teaching is being interrupted by the fire alarm. So the evacuation of students has happened, or if that was a false ring, then she's going to return back to the teaching. So the alarm here interrupts the normal activity. So basically, interrupt is very much needed because the Arduino waits peacefully until an interrupt happens. Imagine, without interrupt, the Arduino repeatedly checks the sensor, which is going to drain out the battery soon. So we need to have an interrupt so that the Arduino can wait until the motion is being, signal is being received, thereby making the system faster and as well as efficient. So the sensor signal will trigger the interrupt, and as a result of which a flag will raise. We will learn more detailedly about the flag as we go through the code. The Arduino reacts, and accordingly any output devices which is being connected will work. So this is the logic, dears. With this understanding, let's go back to our code. Any Arduino programming requires three important things. Number one, initializing the variable, where we have to tell which pins are input, to which pin we are connecting the LED or interrupt, and what's all about debounce, delay, or the trigger pin. So the first logic in Arduino is initializing a variable. Then we will have a void setup and a void loop. This is how we had been programming the Arduino board from our previous sessions. Here, additionally, we have a small piece of code called motion ISR. ISR can be abbreviated as interrupt service routine. Let's not go to detailed description of motion ISR right now. Let's see what is void setup and what is inside the void loop, which will give us a better understanding what could be inside the motion ISR. So let's start with void setup here. So we know that setup function, it runs once when the Arduino starts. Serial.begin is going to start the serial communication. So the messages can appear directly on the serial monitor. Then we have the pin modes. Pin modes are just to set the LED pin as output. And then here you're going to set the interrupt pin as input. We have connected the interrupt pin to D2. So anything which is being connected to 2 is going to act like a input pin. So this particular line sets the sensor pin as an input, followed by the printf statement line. So whatever you put inside the serial.print, it's going to just visualize in the serial monitor, followed by attach interrupt digital pin to interrupt pin motion ISR rising. This is the most important line. Now, as a human being, we understood the importance of interrupt, but we need to convey this to the Arduino Nano and make it understand do it. For that, there are some special functions called attach interrupt digital pin to interrupt. So what this particular 25th line does is, first of all, it will watch the interrupt pin. Where have we connected the interrupt pin? To D2. Okay, so it's going to constantly watch the interrupt pin. And whenever the signal changes from low to high, which means we call this as rising edge. So whenever the signal changes, immediately it runs the motion ISR function. So motion ISR is basically a small piece of code. In an example, what we have learned already, it was about a teacher. So whenever the fire alarm rings, immediately what will the teacher do? She will act in a way to protect her students and herself away from that particular situation. So that's the next sequence of action once that particular interrupt happens. Similarly, whenever the signal is being changed from the low to high, I need to run a piece of code telling how it should react. So I have detected a signal. Now, what should I do? That code is what is being present inside void motion ISR. ISR is called as interrupt service routine. So whenever the interrupt happens, that particular service routine will run. Routine in sense, some set of instructions or a piece of code. Okay, that particular service will start to run. So with this, the void setup is done. Next comes the loop function. We know that the loop function runs forever and it will be constantly checking for a motion flag. So whenever the interrupt function deducts the motion, it's going to reset the flag after deducting the motion. So this is the reason why we use a flag DS. So flag is a concept where whenever you deduct any motion, you need to set that flag to true. And once you have deducted, I'm going to reset the flag to false. So flag is just an indication what the nano gives in order to tell whether the motion has come or not. Okay. So motion flag is equal to false will reset the flag if the motion has been deducted. Then I'm going to have a series of print and statement lines followed by the LED on, a delay, then LED off, followed by some print statements. So the print statements are just can be used for a debugging to check whether the previous line has been executed successfully or not. And the delays, we are giving wait for 1 second and then a small pause before continuing to our next loop. So with this, the void setup and void loop is done. Next comes our most important functionality, which is void motion ISR. Let us get through this line by line, dears. Motion ISR, as I told you already, this is going to define an interrupt service routine called motion ISR, which means it runs automatically whenever the motion is detected. And milli is it's going to give the current time in milliseconds since the Arduino has started to run already. So now represents, like, we are going to check whether we had enough time that has passed since the last trigger, because sometimes there are a lot of chances of multiple false triggers from noise which can happen. So we are defining a variable called now, and we are subtracting the now with a past value, whether it is greater than the debounce delay. Debounce delay we have set here to 200 milliseconds. So if the is a chances of a false trigger which is happening because of the noise, that should be avoided. And that's the reason why we said if subtracted with last trigger greater than debounce delay, then I need to set the motion flag as true and last trigger as now. So what has happened here is, if the condition is true, I'm setting my flag variable to true. This means this is going to set the flag variable telling the main program that motion has happened. So once the motion has happened, the flag will be set to true, and that motion flag will be set to false when it runs in the void loop, means that you have resetted it again. Next, last trigger is equal to now. So this is going to store the time when the motion was deducted. In this way, whenever the value gets repeated, the flag is set up automatically and then resetted again and again, ensuring that our motion doesn't have any false triggers from the noise as well. Okay, so with this understanding, let's run the simulation now. So you can see here the print statements Arduino Nano initialized and waiting for the motion signal as being received in the serial monitor. And now let's simulate the motion of the PIR motion sensor. So once the motion is detected, it will go to the idle condition, thereby saving the battery. And then once you simulate the motion again, the motion will be detected and you can see the LED just glows here whenever the motion is detected. So in this way, you can just click over this motion sensor and click the simulate motion. You can see the LED is being connected to the 8th pin, but here I have mentioned as 3. That's the reason why the LED is not glowing. So just click enable the const int LED pin to 8 here, dears, and run the simulation again. It should work now. Yeah, it's working. Can you see, dears? Once you give the simulate motion, you can see the LED glows. Okay, so always be careful on this. To whichever pin you are connecting the LED, see that you are mentioning that number correctly in the code. This is a beautiful way of showing you how to debug. Okay, So whenever you give simulate motion, you can see that the LED glows, and then in the serial monitor, we get motion detected, returning to idle. So we have understood the concept of interrupt, and then we saw how to utilize the PIR motion sensor and any kind of output device. You can just connect it over along with the Arduino Nano board. We have used the Wokwi platform in order to learn this. I hope all of you understood today's activity. See you all in the next session. Until then, as I always say, happy learning.